Oh yeah, obviously, because my I have my own practice of teaching that you have to know the mathematics and the coding at the same time. Do you mean this? Probably yes. So okay, because I do believe that if you cannot work with the MATLAB and Simulink and you graduate, you're not engineer. In all my classes. Okay. So okay, guys, in the previous class we applied the input of parabolic, and we ended up for the first order system to this graph. And if you remember, because I promised you go through the Simulink, because we have many a few techniques. So if this is input, it's gonna be output. So the error signal increasing, okay, is not constant. Look at the ramp. Look at the ramp. And if this is x, so now going to the MATLAB Simulink. Okay, for the Simulink part, I'm going to show you one trick today. So if this is input to the system and this is output to the system, here is going to be 1 over tau s. But because we don't have parabolic like at the ramp in the Simulink part, so we know that the output over the input for the first order system, generally speaking, I'm teaching the first order system in detail in ME430, but not here. It's gonna be tau s plus 1 when this is 1 over s cubed, and this is, it can be written as 1 over s for the Simulink part. For the MATLAB part, sorry. 1 over s square, 1 over s square in 1 over s, as we did for the ramp. So what is this? What is this? Yes, it's good that you know that, huh? I'm very happy. So you get that the output over step gonna be 1 over s squared, 1 over tau s plus 1. So okay. So on the other hand, you get 1 over tau s cubed plus s squared. So when you go to MATLAB, you're gonna get numerator, but the third order is gonna be 0, 0, 0, 1. This is for s cubed, s squared, s1. For the denominator, you're gonna have tau 1, 0, and 0. See, we change this to this transfer function, but with the step input. So we're gonna go to coding right now. What for the Simulink, guys, we have to put the open loop transfer function, but this is not open loop transfer function anymore because we changed it. That's right. Or you can do this for the Simulink. Because we have a ramp input in the Simulink, remember? The ramp input, see? The ramp input. Okay? So you can say x over y is again 1 over tau s plus 1. So you can write this here as 1 over s squared, 1 over s. So I'm just playing with that. What is this? What is this? Which input to the system is? No. What is this? Ramp. Right? So this is ramp. So having that, you get x over ramp because we have ramp input. See, I'm not sticking to step for the Simulink. So we're gonna have 1 over tau s squared plus s. See, for the coding, we stick to the s cubed. Now we are s squared. So what we want to put in the open loop transfer function because you have to change this, right? So how to do that? As I told you previously, for the unity feedback is going to be G is 1 plus G. So if you found from here, so G of S, open loop transfer function, going to be 1 over tau S squared plus S minus 1. Here we go. So for the MATLAB coding, I'm going to go with the step command that we have with these. For the Simulink, I'm going to go with the ramp input, but with this transfer function. For example, I'm going to stick to tau is equal to 2 for the first order systems. Agree, everyone? So now let me go and I teach you this MATLAB. Then I will go to frequency response. It is very important for any order system. Okay. So what we're gonna do, we're gonna open M file. Okay, so I'm gonna say num, because I'm gonna share with you clear all. Close all. Close all means to close all the figures in MATLAB. CLC means to close the workspace here, and the clear all means that after every run, for the new run, clear all the parameters saved in the workspace. Okay, please do it in your coding always. So num for this is gonna be 0, 0, 0, 1, and then gonna be, I said 2, 1, 0, and 0. And 0. See here? Yeah, close the transfer function for coding in MATLAB with input of the step. That's right. This, see? Tau is 2, 1, 0, 0. And what is the step? Okay. So having that, I'm gonna say figure 1, I'm gonna say step, because I'm gonna use the step command. Num and then and time. So what time? I'm going to say time is from 0 to 0.01 to 15 seconds. And I'm going to define the input to the system. Y was 0.5 t squared. That's right. This is the parabolic. That's right. Input parabolic. So, but be cautious because this is vector. Time is vector. When you are scoring that in MATLAB, you have to put dot squared. If you don't do that, you're gonna give you error, syntax error. Okay. So then I'm gonna say, hold on, and say plot input to the system t and y, and I'm gonna say it is red, grid, title, parabolic, response, and then legend. The first one is output to the system, and the second one is the input to the system. Here we go. I'm gonna save it in the ME530. I'm gonna say parabolic response. Clear? So after that, I'm gonna run it. And you have to see what we derive mathematically. Bear with me. Here we go. Exactly as I promised. So this is input to the system, the output. You see that after time, the error signal, what? Increases. Do you see that? Yes? Good. Oh, now you can also say, okay, I want to plot error signal. Error signal, as we defined, see, is plus minus. Error signal here is input minus output. See, plus minus here is, right, as we did in the simulator. So you're going to say, okay, error signal is input. Input is y, as we defined here, minus output to the system. But what is output? What is output? We don't have it, man. Okay? That's why we go to the Simulink. But before here, because I'm going to share with you, I'm going to say for MATLAB coding, you have to use closed loop transfer function. Okay? Understand? Everybody? But there is another way, guys. ODE, but we are not doing that because we are done with the, as your friend said, the vibration course. We are in the Laplace domain. See what I'm saying? And guys, another things that I want to teach you and put here, there's a command in MATLAB. If I say sys equals to tf num and then, okay, from, if I didn't forget it for a while, long time ago. Let's see what it gives to us. Oops, cut here, guys. 1 over 2s squared plus s cubed plus 2s squared. Continuous time transfer function. If you give num and then, it's gonna give you in the standard form like this. See, 1 over 2s squared plus s. So TF stands for transfer function. TF stands for transfer function. Clear? We give num as we defined below, and then it's closer to 1 over 2s squared plus s cubed plus s. Everybody understand? Good. I'm going to share this to you. But let me go on and teach you another trick. Oh, another trick and in the Simulink. Because when you become advanced control engineer, you have to know how to apply these trivial tricks in the control. Okay. So as it comes up, don't forget that when we go to Simulink, we're going to use the open loop transfer function. But here, based on the ramp input, despite the previous cases that I was applying the step input, I'm using ramp input. So what I'm going to do, I'm going to, okay, I'm going to copy and paste this to here, for God's sake, and I'm going to delete all of these. Okay. So our transfer function, open loop transfer function, now is second order, despite that the coding that's was third order, is 2s squared plus s minus 1. So it's going to be second order 0, 0, 1, and denominator is 2, 1, and 0. Oh, and minus 1, sorry. See, 2, 1 minus 1, the coefficient. So here we go. I'm just saving this as parabolic response. I'm not changing the ramp. I'm changing the just only what to open transfer function. Okay, guys. First of all, I'm making this as 2 input to the system. Okay. And I only for now delete this. Okay. And I will put this as 15 seconds. So if I run this, so you see that this is parabolic input, response, as we saw that. This blue line because there is no connection here. Okay, guys, you let me know. I want that you do brainstorming. So now I want to follow. I'm going to compare the output with the input, but the input is ramp, but I have to have parabolic. What I have to do in the Simulink? That's this to be compared with the output of the system. What do you think? This backs to the high school, not to the university. What? Exactly. So let me, good job. So, see guys, in high school, what happened? Okay. I don't need you. Okay. See that integration of t dt is 1 over t squared. So this is ramp, this is parabolic. But I taught you in the Laplace domain, when you go to Simulink, what is integration? I taught you. What is integration? Go and see that, the Laplace table. I want that you give me the answer. What is Laplace of integration? See your notes? 1 over s. Yes, exactly. So when your friend said integration is enough that I integrate my signal. Get here, guys? I'm gonna put here this and say integrator. Okay, and it comes up. Here we go, integrator. See 1 over s. I'm just dragging here. Okay, so I'm gonna put this here. Then I'm gonna right click on this. And then now you're gonna have parabolic here. See what I'm saying? Yes. Now this output signal is parabolic. Obviously, it's not ramp anymore. See what I'm saying? Yes, everybody? So if I run this, now you're gonna see input, output. Everybody understand? It's very simple. Yes? Okay. Yeah. Yeah. Yes. Before integration it was ramp, but after integration is parabolic. Okay? See what I'm saying? So, and now Okay, you see whatever you learned in high school you're using in the control engineering, right? So now for another example. So if I want to plot from here step function, what I have to do from ramp? You tell me from high school. Yes. So what's differentiating in Laplace domain? What was that? Yes. Now, you mean I have to multiply by s, that's right? See what I'm saying?
Yeah.
Yeah. So let me go back to the notes. These are trivial things, but it's very useful, okay? So you know that d over dt of t is unit step, is 1. That's right, from high school, right? But d over dt, as I taught you, is s, right? The Laplace of that. The Laplace of the first time derivative, now you know, is s. But the point is that MATLAB Simulink has no s. So now you have to make a transfer function like this. Look at here. 1s plus 0, because this is the same, that's right. Here you're going to say 0, 0, 0, s plus 1. So 1s plus 1. Why I'm saying that? Guys, look at here. 1 is much higher than this number. 1 is much higher than 0.0001. So this can be ignored compared to 1. So the result is 1s. See what I'm saying? Yes? Hmm? In Simulink, I mean. Not, yeah, if you want to do that, let us try together, huh? It's interesting. So you can come here and say transfer, okay? So, and if I plug the transfer function here, okay, actually we had it here. So now I'm gonna, as I wrote here, it's gonna be 1, 0, and I'm gonna put 0, 0, 1, and 1. This gonna gives you s, as I told you here. This gonna gives you s, because this 1 is much greater than this, so go bye-bye, and 0, 1. See what I'm saying? So if I plot, if I get a signal from here again, and right click, okay, and if I plot in different, because I'm going to share with you, you have to see step, unit step here, guys. Here we go. If I run this, what do you see, guys? What do you see? Unit step. See what I'm saying?
Yeah.
So that's it. So as I promised you, because I'm going to share with you, the error signal for the parabolic input increases with time despite the case of the ramp. So if I plot this, and there we go. Okay, and I'm gonna put this as, now this is a step, and if I run this, see that, see, goes to, how much is that? 80 for 15 seconds. Obviously minus 80. Okay, because it's obvious why. Why is minus? Because this output is lower than input, so it's gonna be 80. minus 80 with time increasing. Clear, everyone? Yes? Huh? So we are done with the 4 inputs to the system. I'm going to share this with you, the code and the Simulink. And I want to close this because maybe I back, I'm not sure. But I'm closing for now. Okay, let's continue. So speaking in the time domain for x dot plus ax for the physical systems of is equal to f of t, which is the first order systems that we got, say x over f was 1 over tau s plus 1. We applied 4 inputs. 1 impulse, unit step, ramp, and parabolic. But sometimes your f of t is harmonic, is sine omega t or cosine omega t. Harmonic input. Harmonic input. So what's the difference between harmonic and periodic, guys? Do you know that? If you don't know, go and Google it. It's very simple. Okay? So what is interesting in the control class for us is to say, if I increase omega from 0 to a large number, 10 to the power of 4, 10 to the power of 5, if I change the omega, what's gonna be output to the system? What's gonna be output of the system? How it's gonna behave? So the name of this analysis is frequency in the control. Frequency response. This is a technical name. Frequency response. There we go. When you hear from your boss saying that frequency response, you have to make sure that your input to the system is harmonic, sine or cosine. Meaning that change omega from 0 to a large number and analyze the system amplitude. But before going there, if you have, let me cover some fundamental things. If you have this complex number a plus bi over c plus di, this is a complex number. This complex number has 2 values. One of them is amplitude. Another is the phase angle. Phase angle. Amplitude of the A we write as A is A square plus B square C square plus D square. The phase angle of this gonna be the phase angle of the numerator A plus BI minus phase angle of the denominator C plus DI. These are trivial mathematics in complex numbers engineering. This means phase angle. This. So it's very easy, guys. Look at here. If this is real axis and if this is imaginary axis and you have a number here, so this has a real number, like let me say like as B like this, B, A. B is on the imaginary axis, B is like that. So the phase angle of this is going to be this angle. So this angle, let me say phi, phase angle for this number. So tangent of phi from trigonometry of high school gonna be B over A, or the imaginary part divided by real part. I'm writing here imaginary part over real part of that number, real part. So on the other hand, the phase angle of this gonna be tangent inverse or arctangent of B over A. Let me write this. B over A. Clear? Yes? So, having that, so when I say phi for this A, is this means arctangent of imaginary part is B over A minus arctangent of D over C. Here we go. So when you deal with the complex number, you have to find these two parameters. Okay? Understand? So, having been said, for the frequency response, you have to plot 20 log of closed loop transfer function. Bear with me. And also phi versus omega. On the other hand, if this was x dot plus ax is equal to sine omega t, this omega, the guys, the people that they had the vibration course with me, what was the name of the omega here in the vibration course? Do you remember? Excitation. What? Excitation. Yes. Frequency. The most trivial case that you heard recently, it was a catastrophe in Turkey. What happened in Turkey, guys? Yeah, earthquake. Earthquake is, we can model as a for a short period of time as a harmonic input to the system, excitation. See what I'm saying? So we want to change the frequency from 0 to a large number to see how the system behaves. But we are transferring this to the Laplace domain through transfer function. So we're gonna plot 20 log this and phi, this phi. See what I'm saying? So the name of this operation versus omega, I'm gonna do that eventually for the first order system, is Bode plot. Bode plot. We have a command in MATLAB in coding. I'm gonna do that. Yeah. Yeah. No, it's 10. Yeah, sure. It's 10. Based on 10. Okay. So let's go. I told you the output over input of the first order system. I'm emphasizing. I'm only here doing. I'm going to do for the second order system, eventually a higher order system. Okay. Now, because we are done with the first order system, first order systems. And you know that the first order systems were different inputs. So output or input was 1 over tau s plus 1. For teaching purposes, only for simplicity, let me say the time constant of the system is 1. Do you care? No, you don't care. It's going to be s plus 1. S plus 1. First order system. To plot the body diagram. Body, when you say body, simply means change the frequency and see if the output follows the input. I'm going to explain this by many plots. Okay? So, guys, in the beginning of the control class, when I was defining the Laplace, I defined S. What is S? Go to notes. What? Okay, tell me what it's called to what. I want that you tell me from your notes. From the first. No, S. In the control class. Go and see. Yes, I omega. Frequency characteristic, remember? I omega. I defined it. So, because in body diagram, I want to change the frequency, it's enough that I put output over input as I omega plus 1. Instead in S, I'm putting I omega plus 1 because I'm going to the now frequency domain. That's right. See what I'm saying? Good. Can I go to the next page? Yes? Okay. So, X over Y is equal to is I omega plus 1. So I'm going to take out this 20 log of 1 over amplitude of this. Amplitude of this is what? You tell me. 1 plus omega square. You see that I'm taking the closed loop transfer function, amplitude of that, and put here. See what I'm saying? Yes? So now I have to do that. I'm going to say when omega, case A, is a small number, much smaller than 1. I mean this one. When is that? You can say to this, bye-bye. So amplitude of the, this x over, this, let me say A. So amplitude to A becomes, oh, there is a malfunction. Probably because okay. Oh, guys, hold on. So we had A gonna be 20 log of 1 over 1 because I said y to omega because it's smaller than 1. What is log of the 1? What is log of 1? From high school. No, man. What is log of 1? 0. Just Google it. Put it in a calculator. B. Now I'm increasing the omega because this means almost 0. I'm increasing that. B. Omega is 1. See, I'm increasing the omega. By this way, I'm increasing the omega. Omega is 1. So A gonna be 20 log of 1 divided by 2. 1 plus 1. So can you use the calculator and give me the answer? Any of you? Calculate this and give me the answer. I have the answer. Yes, -3. Now I'm increasing more. Case C. I'm saying, so when I say 1, look at here guys, I can write like this. 10 to the power of 0. That's right, 10 power of 1. And I'm saying now I'm increasing to 10 power of 2 frequency. Radian per second. That's right. So it's gonna be a 20 log of 101. Because 100 plus 1. Okay. So it's gonna be how much, guys? Yes, 101. Almost -20. Now look at here. If I increase to 10 to the power of 3, 10 cubed, so it's gonna be log of 1/1001. It's gonna be obviously how much? -30. See what I'm saying? Because it's 1000 plus 1. So if I plot this, guys, the good news is here. And let me put also the E omega 10 power of 4 radian per second. A gonna be, I want that to give me the answer. It's gonna be almost -40. See? -10, -20, -30, -40, 2, 20, 3, 30, 4, 40. See? So if I want to plot this for the first order system, guys, with this transfer function, close the transfer function, okay? So this can be master spring, this can be RC circuit that I'm teaching in the ME430, the tank of the water, okay? This is gonna be omega, okay? I'm gonna say in the logarithm, I'm gonna put that in the MATLAB in the next classes. Let me 10 to the power of 0 means 1. 10 to the power of 2, 10 to the power of 3, okay? So bear with me. You see, for a small number, it is 0. Here is 0. And here is A. This axis is A. 20 log of that. This axis. Until when it's 1, it's going to be -3. So let me, here is -3. So it comes, and here is -3. Here we go.-3. Then it goes to this. It's going to be how much? minus 20. So here say 10 is 20. So here we're gonna go. Okay. And then to the 30 is gonna be 40. See what I'm saying? Okay, this has a name, control engineering. It says when for the low frequencies, your output follows the input, because this is 1, because 1 is 0, that's right. For low frequency, it follows the output magnitude is as the input. Okay. When you increase some certain frequency here, okay, the output amplitude decreases because it's become negative. Your logarithm becomes negative. See what I'm saying? So I'm just plotting here to give you visualization, but I'm going to go to MATLAB for the coding, okay, eventually. Guys, look at here. It says this is input to the system, sine omega t. Okay. For low frequencies, it's gonna be like this. The output. Ballpark, okay? Because I didn't plot the phi yet. But when you increase the frequency, okay, it's gonna be like this eventually. The output of the system. Amplitude decreases. Amplitude decreases. See what I'm saying? For higher frequency. Understand, everyone? Yes? So the output amplitude decreases with respect to the input. The name of this in the control engineering is low pass filter. Low pass filter. If you heard that, means this. Means only the low frequency is being passed. So the amplitude of the output and the input, they are the same. But when you pass some threshold, this is decreasing. So the name is low pass filter. Only low frequency is being passed, while it filters the higher frequencies. See what I'm saying? Yes? So if you increase by this design of mechanical or electrical or tank fluid system with this transfer function, if you increase, you see that it goes down. If you increase the frequency, it's gonna be low. It's gonna filter out the higher frequency. The output gonna be this. Okay. Input is this red one. The output gonna be this. So it's filtering out the higher frequency. Only passes the lower frequency. So the name of this is the low pass filter in control engineering. See what I'm saying? Yes? Now, let me go. I'm going to go over it and I'm going to plot it. I'm going to code it and simulate everything. But first, I have to finish the phase. Oh, I cannot do that. I have to do next class because this is, I have problem with this now. Okay, understand, everyone? So definition of a low pass frequency means this. The first order system with this transfer function. Oh, what is it? With this transfer function. Understand? Yes? What's that? Yeah, low pass filter. Yeah. This closed transfer function is a low pass filter. And I'm gonna plot it in MATLAB eventually. But first I have to finish next class the phase angle. Okay? Understand? Any questions? Okay, first I want to make sure that